When you have an application with huge amounts of data being written every day, a single write instance is usually not enough to handle that scale. So we split one write instance into multiple write instances called shards. With multiple write instances, we also have to arrange the data a bit smartly. For example, if we are storing comments written on social media app, we need to ensure that the comments of a particular post always land on a specific shard, so that when we want to retrieve it, we simply query that one shard and get all the comments of that post. So when a comment comes in, we can extract the post ID, hash it, and then use a simple modulo operation against the number of instances to find the correct shard for this post. Once found, we can easily read and write to this database instance, meaning if a post had a post ID hash of 1234 and we had 4 instances, we could simply do the modulo of 1234 with 4, which results in 2. So whenever we are reading or writing comments for this post with the hash of 1234, it would always be found in instance number 2. Similarly, if the hash of another post ID was 9876, its comments would be read and written to instance number 0. This way, we can ensure that all the comments of a particular post can always be found in the same shard. But what if we want to add a new shard? Meaning if there were 4 shards before, we will now have 5. So now we will have to do a modulo 5 instead of a modulo 4. But this creates a problem. When we do a modulo of post ID hash of 1234 with 5, we get instance number 4, which means that the comments of this post will go in shard number 4. But the problem is that the previous comments of this post before adding this new shard were being stored in instance number 2 and are still there. So when we try to retrieve the comments of this post, our new logic will pull the comments from instance number 4, which doesn't have the old comments. This means that to make all of this work, we will have to move all the old comments from shard number 2 to shard number 4. And we will encounter the same problem for all the posts. Clearly, we will have to redistribute the data according to our new logic. So every time we add or remove a shard, we will encounter the same problem. That is, redistribution of all the data. Well, clearly, this is not sustainable at all. So let's see how we can mitigate this problem. Now, instead of using a modulo operation, let's use another approach. Let's assume that our hash function takes post ID as an input and yields a numeric value which is always between 0 and 100. So we will have a total of 100 possible values. Let's lay these possible values in the form of a ring. Now, since we have 4 database instances or shards, let's place them at 4 uniformly distributed points moving clockwise. So let's say that the 0th database goes at position 0, first database goes to position 25, second database goes to position 50, and third database goes to position 75. Now, we arrange our algorithm in such a way that the hash value of the post ID is always stored in the next clockwise database. Meaning, if we have a post ID which yields a hash of 20, its next clockwise database would be instance number 1. So the comments of this post will be stored in database number 1. Similarly, if we have another post ID which yields a hash of 60, its next clockwise database would be database number 3. So all the comments of this post will be stored in database number 3. Now let's see how this hashing ring solves our problem of changing number of servers. So let's assume that a new database is added and we decide to put it at position 10. Now, according to our logic, if we were looking for comments of post with a hash of 5, going clockwise, we would previously find it in database 1. But in the new system, now we would expect it in the newly added database 4. Meaning, this key has to be moved from database number 1 to database number 4. However, if we were finding comments of a post with hash of 20, we would still find it in database number 1. Meaning, this key and its data does not have to be moved. So after adding a new database server, we only have to move the comments of the post with hashes between 0 and 10. Rest of the keys remain and don't have to be moved at all. This approach is much better compared to the modulo approach, because there we would have to rearrange all of the data. Whereas in this approach, we only have to arrange limited amount of data. And this approach is called consistent hashing. Similarly, if we go back to the original arrangement of 4 databases on the hashing ring and we had to remove a database, let's say database 1, then again only the data which was stored in database 1 has to be moved to database 2, which is again much better than rearranging all of the data with modulo approach. Now, the key advantage of using consistent hashing is that whenever we change the number of servers, be it adding new ones or removing existing ones, only a portion of the data needs to be redistributed, whereas the remaining data continues to reside in its existing servers. Now, speaking of movement of data, there is some clever engineering going on behind the scenes. So let's talk about that a little bit. When we add a new database instance and we want some data to be handled by this new database, we do it in multiple steps. First, we start writing to both the databases. The old database still receives all the writes that it was receiving before. Nothing changes there. But in addition to this, we start pushing the comments which have a post ID hash between 0 and 10 to the new database. At this point, the new database is receiving writes of hashes from 0 and 10, while the old database receives all the writes from 0 to 25, which would also include the hashes from 0 to 10. This way, the comments with post ID hashes between 0 and 10 will be duplicated in both the databases, which is okay for now, because for now, we still read the data from the old database. Now, as the second step, we set up a behind-the-scenes data movement called backfilling from the old database for all post ID hashes between 0 and 10. This step needs to be done very carefully with proper mechanism to ensure appropriate failure handling and retries so that in case something fails during data transfer, we can always retry. And when we retry, we also have to ensure idempotence to enforce that in case a record is resent, the database ignores the duplicates. To see a deep dive on idempotence, you can check out my other video dedicated to this topic. Finally, once all the data with hashes between 0 and 10 is successfully migrated, we point the reads and writes of all the hashes between 0 and 10 to our new database. And then we point the reads and writes of all the hashes between 10 and 25 in accordance with consistent hashing. Once everything is in order, we delete the comments with post ID hashes between 0 and 10 from the old database to free up the space and make room for new comments with hashes between 10 and 25. Similarly, in case a database needs to be removed, we do something similar. We remove the database only when all of its data is successfully migrated and functional. In reality, there may also be virtual nodes to distribute the data at a more granular level, but that's beyond the scope of this video. Now, let's talk a little bit about values on the hash ring. We talked about an oversimplified hash function, which yields values only between 0 and 100. This was only for the sake of simplicity. In real life, you would use a simple hash function like murmur hash, which always yields a 32-bit output. Meaning, all of its possible values would be between 0 and 2 to the power 32. And these values would actually be distributed across the hash ring. So the values on the hash ring depends on the hash function being used underneath. If we were to use SHA-1 hash, which yields a 160-bit output, the possible values in the hashing ring would be from 0 to 2 to the power 160. However, cryptographic hash functions like SHA-1 are usually avoided in favor of better performance offered by non-cryptographic hash functions like murmur hash. So, when to use consistent hashing? For a system design interview and even real architecture choices, it is to be remembered that it's a concept which can be applied anywhere depending on your use case. So whenever you have a requirement where you want particular data or request to land on the same instance, consistent hashing can surely be one of the top contenders for that use case. So that was it, folks. See you in the next video. Bis dann.